Dear students, today we'll continue our practice on mathematics. So today's topic is Cartesian product and relations in plane, monomials and polynomials, algebraic fractions. So let's begin with Cartesian product. To define Cartesian product, firstly we need to define ordered pair. So definition. An ordered pair is a pair of objects where one element is designated first and the other element and the other is designated as second. And we denote ordered pair with A and B, for example. So this is we call ordered pair. So now the definition of Cartesian product now. This one is definition of ordered pair, and we will use this definition to define Cartesian product. Definition 2. This is 1. Okay, so the Cartesian product of two sets A and B, and we denote it by A like this times B. This is Cartesian product, is the set of all possible ordered pairs. All possible ordered pairs where the elements of A are first and the elements of B are second. So such kind of set we call Cartesian product. So if you want to write it in set builder notation, we have A Cartesian product B equals to, so set such kind of ordered pairs where A from the set of A and B, this little b from the set of B. This is we call Cartesian product. Example. Let's give a first example. Example 1. So here let's define two sets, A and B, and then define Cartesian product. So A is H and T, for example, and B is 1, 2, 3, 4, 5, 6, for example. Yes. So now we need to define A Cartesian product with B. So this is all possible ordered pairs. Here the main sentence. All possible ordered pairs. So it will be, in our case, set. So the first ordered pair is H1. The second one is H2. And similarly till H6. H3, H4, H5, H6. And now we'll begin with T. So T1, similarly, yes, T2, T3, T4, because first element should be from first set and the second element from second set. This is Cartesian product. So all possible ordered, the set of all possible ordered pairs. T5 and the last one is T6. So this is the set of all ordered pairs for A and B. And if you want to write the inverse one, B and B Cartesian product of A, it will be little different with the first one, AB, because here now we have 1H and 2H, 3H, so 4H, 5H, 6H. Now first element from B and the second element from A. So then what we have, so if we continue, it will be the next ones are 1T, 2T, 3T, 4T, 5T, and 6T. So this is the second product, B and A, B Cartesian product of A. So here what we get, the B, they are not equal. So A Cartesian product with B is not equal with B Cartesian product with A. They are not equal. So we can conclude here. So the Cartesian product is not commutative. This is Cartesian, we call Cartesian product, such kind of product. And let's consider the next example. So let A, set A is consists of A1, A2, AN, and elements, and compute the cardinality of the power set of the set P AM. P, it means the power set. So now if the set A has n elements, then here we need to find m, a the power of m. Yes, so it means m's Cartesian power. So m's Cartesian power of A. So this is A m's power. It's equals to A and A. So how many times? M times of A. This is m times. Yes. And now we can write A times A times. So this is also m times. Then each A has n elements, so it means here we have n. So the cardinality of A is just n. So n times n times n, etc. So it's also how many times? M times. So it means we have n times m. So we have n times m. And now the cardinality of the power set of am, so P of am, this is the number of subsets of am's power. If it is just A, it was 2n, yes, but in our case we have m's power, so and we get here am, cardinality of am, so this is n times m. So in this case we have just 2 the power of n times m. This is cardinality of the set A the power of m. And what is a relation? So the relation is a set of ordered pairs. For example, any set of ordered pairs, 0, 1, 2, 3, 1, 4, for example. Yes, this is we call relations. And now we will move to the next section of our lesson. So monomials and polynomials. So let's firstly give a definition to monomials. And what's monomials? Monomials is a monomial is any product of numbers and variables. We can give such kind of definition to monomials, or we can define it differently. For example, a monomial is an expression that contains one term. So these two definitions are equivalent. So one more time, a monomial is any product of numbers and variables. For example, we can consider as monomial number 9. This is also monomial. Or 2ab, it's also monomial. Or 4y squared, or minus 7y squared and the x 4th degree, for example. This is also monomial. So they are monomials. And here this 2, 9, 4, minus 8, this is coefficients of monomials. And coefficient of monomial, it is the numerical part of this expression. So now a binomial. Of course, a binomial, it's a sum of two monomials. For example, 9 plus 2ab, this is binomial now. Or 4x minus 2y, it's also binomial. Or 4 a squared b cubed minus or plus 2 cd fourth degree, for example. This is also monomial, binomial. Binomial, it's the sum of two monomials. And now we have a polynomial. So a polynomial is a sum of n monomials for some whole number n. So monomials, binomials, and we have trinomials are all special cases of polynomials. Now we have a degree of monomial. It's the sum of the exponents of all its variables. This is degree of monomial. And we have the degree of polynomial. This is the term of the polynomial that has the highest degree. It is degree of polynomial. So for example, polynomial will be, for example, 3x cubed minus 4ab squared plus 3y minus 1, for example. This is also polynomial. And now what we have here we have main, so here we have subtraction, adding, multiplication, and division. So adding two polynomials, for example 2 a squared b minus b cubed, for example, and we need to add to this polynomial. This is first polynomial. Binomial is also polynomial. So plus 3ab squared and minus 2a cubed and plus a squared b. So firstly, we need to find here like terms of this polynomial. Do we have like terms? So we have like terms a squared b and a squared b. They should be same, and then we call them like terms. So in this case it's, and now we can add these like terms, and we have 3a squared b. Then the other ones will be there are no change, so minus b cubed plus 3ab squared and minus 2a cubed. They are without change. So this is adding or subtracting two polynomials. And we have, for example, multiplication of polynomials or binomials. For example, 2ab minus 5. We need to multiply by 3a squared b plus 2a, for example. Yes, so let's multiply, and we need to multiply this each terms. So we have 6a cubed b squared. 2ab times this one, a to a and b to b. And here also we have plus 4 a to a, we have a squared and just b. And then minus 5 times 3, it will minus 15. And we don't have here a or b, so a squared b now. And the last term, it will be minus 10a. This is multiplication of two polynomials. And now one more example. So for example, if we need to open the brackets here, for example, 3x cubed and then 2x squared minus 4xy minus 9 y squared. So here again we need to multiply this term, first term, to each term. So this is multiplication monomial to polynomial, and we get here 6x, x third, x second. This is the from the rule of natural exponents. We need to add the powers. This is previous we showed in previous lessons. X fifth power, then minus 12x fourth y, and the minus 27 x cubed y squared. So this is multiplication. And now we can divide two polynomials. For example, 3a squared b plus ab cubed, for example. So we need to divide by, this is first polynomial. Now the second one is a cubed b squared and plus or minus ab squared, for example. So now how to divide them? So let's write it in fraction and factorize it. We can factorize them. So we have here a squared and a, b and b cubed. So we can take out from the brackets just ab, what we have in both of them. So ab, then here we get a plus b squared, and in the next one in the denominator we have also now again ab we need to take out, and a squared b minus b. So we can cancel these two ones and we get the answer 3a plus b squared over, so a squared b minus b. We call such kind of expression algebraic fraction. And now I want to recall short multiplication formulas. So first formula, this is square of sum. Square of sum, it is a plus b squared equals to a squared plus 2ab plus b squared. This is square of sum we call. The next one is square of difference, a minus b squared. So it's equals to a squared minus 2ab plus b squared. And the third one, cube of sum. So cube of sum, this is a plus b cubed. So it's equals to a cubed plus 3a squared b plus 3ab squared and plus b cubed. It is cube of sum. And similarly, we can define the cube of difference, a minus b cubed. So it will be a cubed. And pattern of signs minus 3a squared b plus 3ab squared minus b cubed. And the next one, number 5. This is difference of squares. So it is a squared minus b squared. It will be a minus b and a plus b, the difference of squares. And the sum of cubes, next one, it is a cubed plus b cubed. So it will be a plus b, a squared minus ab plus b squared. And the next one, number 7, difference of cubes. So it is a cube minus b cube. It will be a minus b, a squared plus ab plus b squared. You can check all of them by just multiplying. For example, if you want to find this for a plus b squared, square of sum, so we need to multiply a plus b 2 times and we get this answer after simplifying. And similarly, we can find other ones also. And also we can add here the square of sum of 3 terms, a plus b plus c squared. It will be a squared plus b squared plus c squared plus 2ab plus combination of a, b, c. So 2ac and plus 2bc. And this is the square of this sum consisting of 3 terms. And let's consider the example here. So, for example, 9y squared minus 1 plus 2y squared. So we can solve this example. Write this expression as product of 2 expressions. So now we can use these formulas, and for example we can open the this second one with the formula square of sum, but you need to write it as product of 2 terms. So that's why we need to use here which one? The difference of squares. So it is number 5 in our case. This one we will use. So the first one, as a squared, we have 3y squared, and minus the second one is in squared, 1 plus 2y squared. So now let's use our formula, a minus b, a plus b. So 3y minus 1 minus 2y, and the 3y minus plus 1 plus 2y. So now after simplifying, we'll get the y minus 1 in first brackets, and in the second bracket 5y plus 1. So this is the final answer. Or let's consider the next one. For example, so if we want to open the brackets, let's do the next one. So a 6 power times b plus c squared cubed. So firstly we need to open by the third formula, cube of sum, and then multiplying by a to the power of 6. So a to the power of 6 in brackets. Here we have, using the formula, third formula, we have b cubed plus 3 times b squared times c squared plus, so this is another example. So plus the next term will be 3a, in our case this is b, and c first power plus last term in cube, so c 6 power. Okay, and then when we continue, so we have a 6 times, so b cubed plus 3b squared. So let me just directly multiply by a, all of them. So ab cubed plus 3b squared c squared a6, and plus 3a6 bc fourth, and the last term plus a6 c 6 power. We have this answer. And now let's move to the algebraic fractions. So the first example, reducing the algebraic fraction. For example, exercise number 1. So here we have the following fraction: a cubed minus 2a squared b over 2a cubed b squared minus a fourth b. So now we need to reduce this fraction. So to reduce this fraction, firstly we need to factorize it and factorize numerator and denominator. So in numerator we can take out from the brackets a squared. Here we have a minus 2b, and from denominator we can do a cubed and b. So, and we have 2b minus a. So now can we cancel a squared with a cube? Of course, if we cancel them, we have just a in the denominator. And we can also cancel a minus 2b with 2b minus a. They are different with minus 1, so difference between them, this is minus 1, and if we multiply by minus 1 of them, we can get the corresponding expression. And here when we cancel them, we have we need to multiply minus 1, so the answer is minus 1 over b. Okay, next one. The next one, so for example, 4c squared minus 9x squared over 2c minus 3x. So here firstly we need to use in top the formula. So difference of squares. So when we use the formula, short multiplication formula, we'll get here 2c minus 3x, because this is 2c squared, this is 3x squared, and 2c plus 3x, or 2c minus 3x. And now we can cancel them. We have 2c plus 3x. Now, the next example. Okay, so the next one is so 1 minus 2p, or 1 minus 4p plus 4p squared. So this is when we're reducing this fractions, again we need to reduce it, and in bottom we have formula a minus b squared. So the square of difference, top is without changing, 1 minus 2p, but in bottom, in denominator, we have 1 minus 2p squared. This is formula. And now we can cancel one of them, and we have 1 over 1 minus 2p. Okay, next one. Number 4. So, now, what kind of, so, okay, 50m squared plus 100mn plus 50n squared over 15m squared minus 15n squared. Now, firstly, in top, we need to factorize firstly. Let 50, and in brackets we have m squared, take out this 50, and we have m squared plus 2mn plus n squared, over here 15, so it is m squared minus n squared we will get. And now if we continue, so this is, we can cancel by 5, it's 10, this is 3, 10. Now this is formula m plus n squared, over here also we have formula m minus n, m plus n. So we can cancel one of them, m plus n, and we'll get 10 m plus n over 3 m minus n. This is answer. Okay, and now, okay, let's do the next examples. So the next one, eight c cubed minus 1 over 4c squared plus 2c plus 1, reducing algebraic fraction. So this is formula a cubed minus b cubed, because it's 2c cubed minus 1 cubed, over here we have 4c squared plus 2c plus 1. This is not formula. So now let's use the formula difference of cubes. So we have here 2c minus 1 times, now 2c squared, this is 4c squared, and the plus 2c times 1, it's just 2c, and plus 1 squared, it's just 1, over 4c squared plus 2c plus 1. So now we can cancel these two ones, they are same, and we have just 2c minus 1. And now adding algebraic fractions. So exercise number 6. Now let's consider this one. 2x squared minus m squared over 2mx plus 1 minus 2x minus 1 minus m over x. So now, firstly, we need to give a common denominator to all of them, and the common denominator in our case will be 2mx. And this is same with the ordinary fractions. So now here we need to multiply 1, here 2mx, and here 2m. And now let's write our denominator 2mx, and here we have 2x squared minus m squared plus 2mx and minus 4mx and minus 2m squared. So after simplifying, we get 2mx in the denominator, and in top we have 2x squared minus 2mx because of this one, and here we have plus, of course, because minus and minus we get plus. Here in the middle we have minus, so when we multiplying we have here plus, and minus m squared plus 2m squared gives us just m squared plus m squared plus m squared. That's all. Okay, now next example. So exercise number 7. So 5 over 2x minus 2 plus 3 over 4x minus 4. Okay, now firstly we need to factorize the denominators. So we have 5, 2x minus 1 plus 3 over 4x minus 1. And now we can say here just 4x minus 1, it will be the common denominator for both of them. So here we need to multiply just 2, and we have 4x minus 1, here 10 plus 3, or 30 over 4x minus 1. This is answer. Okay, now so the next example. A minus 2 over a plus 2 plus a plus 2 over a minus 2. So now we need to multiply these denominators and do common one. So the common one is just a minus 2 and a plus 2. This is formula, yes. So here we need to multiply a minus 2, and here we need to multiply a plus 2. So we have a minus 2 squared, yes, because of 2 times a minus 2, and plus a plus 2 squared. So this is our denominator. And now let's open our numerator. So it is a squared minus 4a plus 4, and plus a squared plus 4a plus 4. They are cancelled. and we have a minus 2a plus 2. So 2a squared plus 6 equals 4 plus 4. 2a squared plus 6. 8, sorry, here 4 plus 4, and we get here 8. Not 2, it is 4. So now a squared, so we can write here, just simplify, after simplifying, 2a squared plus 4 over a minus 2. So here we have a squared minus 4. This is answer. Okay, next one. So for example, exercise number 9. So next example, so c squared minus 8 over 2c plus 3 minus, in the middle, 16c minus 2c cubed over 9 minus 4c squared. So we have here c squared minus 8 over 2c plus 3, but the second denominator we can factorize minus using the formula. Which formula? Yes, of course, difference of squares. So here we have 3 squared minus 2c squared. It is 3 squared minus 2c squared. So now we have 3 minus 2c and 3 plus 2c. So the common denominator will be this one. This is common denominator for us now. Okay, if you continue, we have 2c plus 3 or 3 plus 2c and 3 minus 2c, and now what we need to multiply to the first one, it's just 3 minus 2c. So here now 3c squared minus 24 minus 2c cubed and plus 16c. Then the next one, it is just minus here 1, yes, minus 16c and the plus 2c cubed. So now we can cancel like terms, 2c cubed with this 2c cubed with minus, and we have 3c squared minus 24 over this one. Three plus 2c and 3 minus 2c. Now we can factorize them, but they are not cancelled, they are not reduced. So this is answer. And let's consider the next example. So 2a over 25 minus 10a plus a squared and minus 10 over a squared minus 25. Okay, so firstly, in first algebraic fraction, you need to factorize denominator. So 2a, this is formula. Yes, you are right. So this is formula for a square a minus b squared, the square of difference. And here our a is just 5. Our b is just a. So 5 minus a squared this is. And now the next one is minus 10 over, here also the formula. So difference of squares, a minus 5 and a plus 5. And here, pay attention, this 5 minus a squared, we can write a minus 5 squared if it is in squared. So a minus b squared is equal to b minus a squared. So you can check it. This is for you problem. So a minus b squared, it's equals to b minus a squared. So we can replace this one as 2a over a minus 5 squared. If it is in only even powers, we can do it. And minus 10 a minus 5, a plus 5. Now the common denominator is a minus 5 squared times a plus 5. So here we need to multiply a plus 5, and to the second one a minus 5 again. Okay, so let's continue. And we have here a minus 5 squared, a plus 5. Okay, here we have 2a squared plus 10a minus 10a, and minus minus, it will be plus 50. Okay, so they are cancelled, and we have 2a squared plus 50 over this one, a minus 5 squared, a plus 5. We can factorize this one, take out 2, but that's also, it's not reducing. Okay, now the next example is, so for example we have such kind of examples: a squared, a plus 1 minus a plus 1. So doing operations, and here the common denominator is a plus 1, so you need to multiply here a plus 1 to this one and to this one also, to this term. So then we have a plus 1 in denominator, and in numerator a squared minus a plus a plus 1. So they are cancelled. A squared with a squared minus a with a also cancelled, and we have just 1 over a plus 1. Now we have multiplication and division of algebraic fractions. For example, let's consider any division. So ab plus b squared over 9 divided by b squared over 3a. Firstly, we need to factorize this first fraction, algebraic fraction, and it will be b, a plus b over 9. And now division change to multiplication, and we will take the inverse fraction to this fraction when we take the multiplication. So it will be 3a over b squared. So here we can cancel b with one of this b, and 3 with 9. Here's 3 we have. So the answer is a times a plus b over 3b. This is final answer. Okay, and now let's try to find the next example now. So exercise number 30. A squared plus b squared over a squared minus ab divided by the next fraction a4b minus b fifths a2b minus ab second. Okay, so now firstly again we need to factorize. When we have multiplication and division, firstly we need to factorize always. So a squared plus b squared, but in the bottom we have a minus b. Then division changed to multiplication, and taking second one divisor is inverse fraction. So here we have b. It's so ab in from denominator ab, and we have a minus b. Yes, a minus b, and in top we have just b and a4 minus b4 here we have. So they are cancelled, a with ab with ab, and we get here a squared plus b squared over just 1 here, and here times b, so over a4 minus b4, they are also cancelled, b with b, so we have just 1 here. So a4 minus b4 gives us a2 minus b2 by the formula difference of squares, a2 plus b2, I mean squared. So, and now they are also cancelled, and we have 1 over a squared minus b squared. Okay, now let's do the next example. So exercise number 40. Okay, for example, let's do this one, a b over a minus b times 1 over b minus 1 over a. So here we have a minus b, and in brackets the common denominator will be ab, here a, here b, so it is ab times a minus ab, so this is denominator, and numerator is a minus b, so we can cancel them. And we have answer 1. And then I want to show the last example. So calculate this expression, and firstly again we will find the inside of our brackets, and here we have the following one. So a plus 1 over let's factorize each of them. So 2a minus 1 plus 6 over 2a squared minus 1, and here we have a plus 3 over 2a plus 1. Okay, so then divide by, so factorize this one also. Let 4a squared minus 1 over 3. And now the common denominator here is just 2a squared minus 1, because here we have a minus 1. If you open it, a minus 1 and a plus 1. So here we need to multiply a plus 1, and here just a minus 1. So then we have 2a squared minus 1. So here we have in top a squared, this is formula, a plus 1 squared, a squared plus 2a plus 1 plus 6, and the minus here we need to multiply, minus a squared minus 3a plus a, because 2 minuses, and plus 3. Okay, so they are cancelled. So multiply now. So here just multiplication, not division. If it, so in our book here we have just multiplication. So multiply by 4a squared minus 1. Multiplication here, and over 3. Okay, they are cancelled. When, so one more time I will repeat, when we can cancel two fractions, when they are factorized to factors. So here they are, we can cancel them, and 4 with 2, here 2. And now let's compute the numerator. It is 2a minus 3a. They are also cancelled. Look here, 2a plus a, this is 3a, 3a minus 3a, it's 0. A is also cancelled. And we have here 7, 1 plus 6, and plus 3. So 7 plus 3, this is 10. So the answer is 10 over 3. This is final answer. Okay, so you can continue at home solving such kind of examples in algebraic fractions, and of course to Cartesian product and monomials and polynomials. If you have any questions, you can write to us, to your professor, in by your by the system LMS. So there are, you have question and answer forum, and you can write there your questions. And the next time we'll continue our practice. Thank you for attention.